So let's continue exercise 8.1. Let me do the question number 8. There you want to get the value of 101 raised to 4 using what? Binomial theorem. So as we did earlier, how do we write this? This will write, 1 plus 100 raised to 4. Now you just need to recall, if you remember, the expansion of binomial theorem. So by here binomial theorem, what is expansion? 4c0 into 1 raised to 4, 4c1, now decrease the power of 1, which is 1 raised to 3 into 100, plus 4c2, no need to write now power of 1 because it's always 1, so you write 100 square, plus what's this? 4c3 into 100 cube, and finally last term 4c4 100 raised to 4. Now this calculation won't be difficult for us because here you have maximum zeros. What's 4c0? It is always 1 into 1. What is 4c1? It is 4. 4 into 100 as it is. This gives us 400. What is 4c2? It is 4 into 3 into 2 factorial. That will get cancelled with this. So just you have by 2. So you have 6 into 100 square. 4c3 is same as 4c1. So which is just 4 into, here 100 cube. And finally 4c4 is just 1 into 100 raised to 4. So this will be 1 here, plus what about this? This will be just 400. What about this? Here 1 followed by how many zeros? 4 zeros. So 6 into 1 followed by 4 zeros, right? 4 into cube means 1 followed by how many zeros? 6 zeros. And here this is 1 followed by how many zeros? 8 zeros. Now we just add them. This is nothing but 10,000 into here 6, which is 60,000. Here this one into 4, and then just to add them, so we get this after just adding this. It's simple algebra, remember. 1 0 4 0 6 0 4 0 1. That's just simple addition. 1 plus 400 plus 60,000, 4 into this plus 1 into this, 1 followed by this. This just to remind you, remember. I know this is very simple. What about next question? The same way you can do 9th. What about 9th question? That's 99 raised to 5. I'll do one step for you. 99 you can write as what? 100 minus 1, the whole raised to 5. Now we just expand by binomial theorem. So this is 5c0 into 100 raised to 5, plus here 5c1, now decrease the power, so raised to 4, and now you have power of minus 1, that's just 1. Then 5c2, you have 100 raised to 3 into minus 1 the whole square. Every time power should be 5, remember. Plus, what about this? 5c here 3, 100 here squared, and minus 1 cube, remember. 5c4, here you're just 100 raised to 1 into minus 1 raised to 4. And finally the last one, 5c5, this is 100 raised to 0 into minus 1 raised to here 5. So here your minus sign, here your minus sign, and here your minus sign, because here your odd powers. Just simplify, so you will get the answer. Or let me do it, no problem, I'll be doing here. I'm just simplifying. See, what is 5c0? It is 1. Here I'm just simplifying this. 5c0 is 1. 100 raised to 5 means what? Here. So 100 raised to 5 means 1 followed by how many zeros? Raised to 5 means 10 0. 4, 5, 6, 7, 8, 9, 10. Plus 5C1. You know 5C1 is always 5. 100 raised to 4 means 1 followed by how many zeros? 8 0. 6, 7, 8. Okay. Into minus 1. So here you have minus sign actually. What's 5C2? You know it is 5 into 4, 20 by 2, which is nothing but the 10, remember. 100 followed by 3 here raised to 3 means followed by how many zeros? 6 0. This is just 1, remember. 5C3 same as 5C2, which is 10. Here 1 followed by how many zeros? 4 zeros. Raised to 2 means 4 zeros. Minus 1 cube means here minus 1. 5C4 is same as 5C1, which is again 5. Into 100 here, this is just 1. What's 5C5? It is just 1, and into minus 1. You simplify, so you'll get the backside answer. This is what you need to do. Fine. Now we go to next question. Question number here 10. This is a good question. What is asked in this question? Decide 1.1 raised to how much? 10,000. Or just 1000, which is larger of these two. So we just expand. We'll realize immediately. This is 1 plus, you can write 0.1 raised to 10,000. Right? 1.1, you can write 1 plus 0.1 raised to 10,000. Now what we do? We just expand it by binomial theorem. Okay, so you know how to expand this. Let me expand here by binomial theorem. If I expand this, the first term will be 10,000 C0. 10,000 C0 into here just 1, you know. Plus, what's the second term? That is 10,000 C1 into 0.1 raised to here you know just 1 if you remember. Here it is raised to 0. You just recall the expansion of 1 plus x raised to n. You immediately will realize it is nc0 plus nc1 into x plus nc2 into x squared if you remember, and so on. I'm just indirectly using this. Plus, what about this? If you want one more term, 10,000 C2 into 0.1 the whole square, and so on. And so on, dot dot dot. Now you will realize here immediately. What is 10,000 C0? It is always 1. What is 10,000 C1? It's 10,000. The value of this one is 10,000 into you have 0.1. And so on. These all are positive terms, remember, plus some positive terms. The answer will be whatever it is, but it's a positive value, remember. So this is 1 plus 10,000 into 0.1, so it is 1,000. Plus some positive terms. So, have you realized? What's the conclusion? You are asked whether it is a greater than 1,000 or not. So obviously 10,000 plus 1 something positive value, remember. So this has to be greater than 1,000, remember. So what you have concluded, 1.1 raised to 10,000 is greater than 1,000 by binomial theorem. This is always true. Remember, 1.1 raised to 10,000 is bigger than this. If you want just one more, you can go to just refer example number 3. You will realize similar example. Go to the example number 3. It's the same question. Example number 3. Okay, fine. Now, next question. The next question is, you find the value of a plus b the whole raised to 4 minus a minus b the whole raised to 4. So how we'll do this? We expand both by binomial and we just get the difference. Okay, so let me expand first one. 4c0 a raised to 4, 4c1 a cube into b, 4c2 a square into b square, 4c3 a into b cube, and last term is 4c4 b raised to 4 minus now the expansion of the other expression. Okay, so let me expand the other expression minus, I'll write inside the bracket here, same 4c0 a raised to 4. Here your minus b, remember. So because of this minus b, here we have minus sign. 4c1 a cube, actually it is minus b, but b minus sign already taken outside. Here minus b square, so this remains positive. 4c2 a square b square. This is odd power, so here minus 1 will come out. 4c3 a b cube. And here even power, so 4c4 b raised to 4. Now you will see half of the term will get cancelled and half will be double, remember. So if you open the bracket, see here this minus, so this term and this term will get cancelled. This will be plus, so this will be double. So twice 4c1 a cube b. Here this is minus, this is plus, so this will get cancelled with this, remember. Now here you have plus, so this is plus twice 4c3 ab cube. Right, this will be double. Now when you take minus inside, here you minus and this is plus, so here this will get cancelled with this, remember. So we are just left with this 2. You can simplify this. What's 4c1? It is just 4 a cube b. 2 already taken outside. What's 4c3? It's same as 4c1, so it is just 4 a b cube, remember. 4c3 is same as 4c1 and 4c1 is 4. Again you can take 4 outside, so it will be 8 and you have a cube b plus a b cube. Even if you want one more, you can take here also a b outside. So here you are left with a square and there you are left with b square. This is simplification, right? So the final simplification is here 8ab a square plus b square, remember. Now further also you are asked to find the value of this. Evaluate this. Hence means use above expression. Root 3 plus root 2 the whole raised to 4 minus root 3 minus root 2 the whole raised to 4. So what is your a here? Just compare with this. So a is root 3 and what is b, which is root 2 here, right? We are just going to place here, so therefore value equals to here 8 into ab, which is root 3 into root 2. Then a square means 3 and b square means 2, right? So what we'll get finally, that's 5 into 8, which will be 40. This is 5 into 8, so 40 root 6, that's required value, remember. 40 into root 3 into root 2, which is root 6. 8 into 5, that gives us 40. Fine. Next question, 12th. You are asked to find the value of this expression. So it's like previous question. We expand this, you will see that the number of terms will get cancelled. So I'm just expanding the first one, binomial theorem, remember. 6c0 x raised to 6, 6c1 x raised to 5 into here actually 1 raised to 1, but that I'm not going to write. 6c2 x raised to 4, 6c3 x cube into you have 1 cube, remember that I'm not writing. 6c4 x raised to 2 plus you have 6c5 into x and finally 6c6 into x raised to 0, that's 1 plus now we'll continue with this. I'll write here plus, here your minus sign, remember. So now you need to be little careful. 6c0 x raised to 6, 6c1 x raised to 5 into minus 1, so this will be minus and therefore this will get cancelled. 6c2 x raised to 5 x raised to 4, sorry, but here your minus 1 square, so this will be positive only, plus here 6c3 x cube into minus 1 cube now, so this is minus 6c4 x square into minus 1 raised to what? 4. This is even, remember. So this remain plus only. 6c5 x into minus 1 raised to 5. And finally 6c6 into minus 1 raised to 6. This is even. So you will see that number of terms will get cancelled. And many of them will be double. Half of them will be double. So here this and this will get cancelled, because here your plus and because of this minus, this will get cancelled. Here your x cube, here your minus x cube, so this will get cancelled with this one. This is plus only. Here because of minus 1 raised to 5, here your minus and here you have plus, so this will get cancelled with this. Okay, now what about the remaining term? This one and this one, this will be double, so I'll write twice 6c0 into x raised to 6. What about this? X raised to 4, here also x raised to 4, this is positive again, remember, so this is also double. 6c2 into x raised to 4, plus what about this? X square, 6c here x square, this is also positive, so this will be double, remember, 2 already written outside, so 6c4 x square. And finally the last term, this is constant, here this is constant, so plus 6c6 here into just 1. Now question is just you need to simplify this, that's what all in all about the value here. 2 as it is. What is 6c0? 1. 1 into x raised to 6. What is 6c2? It is, if you remember, 6 into 5 into 4 factorial. That will get cancelled with the denominator. So into 2. That's the value of this. Into x raised to 4. 6c4 is same as 6c2. So 6 into 5 by 2 into x square. And 6c is just 1. And therefore now finally last step. If I write here, so twice, this is x raised to 6, this is just 15 into x raised to 4, 15 into x square, and finally it is just 1. And now with the help of this, you can just calculate the value of that expression. Which expression? Root 2 plus 1 whole raised to 6. So take, x equals to what? Root 2, right? Plus 1 is already there. Root 2 plus 1, right? Just look at here. Root 2 plus 1 whole raised to 6. Root 2 minus 1 whole raised to 6. So just take x equals to root 2 in this expression. So you'll get the value of the expression, final expression. Simplify this. Now that much you can do. Okay. Next question. Question number 13, this is an important example here. Question says you show that this expression is divisible by 64. You are given this expression 9 raised to n plus 1 minus 8n minus 9. You want to show that this is divisible by 64. Divisible by 64. So what we'll do, we'll show that this expression equals to 64 into some constant. Right? If you remember PMI questions, we had such questions. The same question you can do by PMI also, remember. But here we are using binomial theorem. So what I'll do, I'll start with this. 9 I'll write as 1 plus 8 whole raised to n plus 1. Question is why I wrote 9 as 1 plus 8? Because I want power of 8. I need 64, that's why. You cannot write 10 minus 1. If you write 10 minus 1, you will get the power of 10. You don't want power of 10. You want the power of what? 8. 8 square, 64. right? That's why minus 8n minus 9 as it is. Now for this we use binomial theorem. Here we'll use the binomial theorem for this term only. This one we keep as it is. So I'm using binomial theorem. N plus 1 C0 into 1, if you remember, plus n plus 1 C1 8 raised to 1 plus n plus 1 C2 into 8 square, and so on. If you want to, let's write one more. N plus 1 here C3 8 cube, and so on. Last term, if you want, you can write n plus 1 C n plus 1 into 8 raised to n plus 1. What about these two terms which we are going to copy here? Minus 8n minus 9. We are doing nothing with that, remember. उसको आपको कुछ नहीं करना है. That will keep as it is. Okay. What I've used? Simply binomial theorem, remember. 0, 1, 8 raised to 1, 8 square, and so on. Here this is 1, remember. So you have 1 raised to something which is 1. So that I have not written. Now this is equals to NC0 is always 1. N plus 1 C1 is n plus 1 into 8. What about this? Now onwards, if you observe U164, you see, now no need to simplify. From this term onwards till this last term, you will find 8 square common. So I'll take 8 square common. So here what we'll get? N plus 1 C2 plus n plus 1 C3 into 8, and so on, remember. Here actually if you take 8 square common, so we'll get 8 raised to n minus 1. But that's not important. We can write dot dot dot. Minus 8n and minus 9 as it is, remember. What I did? I have just taken 8 square common from these terms. Except the first two terms, from all the remaining terms of the binomial theorem, I have taken 8 square common. These last two terms we are keeping as it is. We are doing nothing with this, remember. Okay. Now if you open this here, what is this? 1 plus 8, that's 9. And this is nothing but the 8n plus this is 64. Whatever it is, but it would be some integer, remember. So I'll write a small m. Minus 8n minus 9. Where what is m? Where m, small m is this. N plus 1 C2 and so on, right? It's an integer, remember. This 2 will get cancelled with this. So what we are getting here? 64m, where m is in some integer. ये value एक number positive integer ही होगा, remember. So what you have shown, look at it, the final expression, 64 into some integer. You had started with this, you have used the binomial theorem, you showed that there's a 64 into m, and therefore 9 raised to m plus 1 minus 8m minus 9 is divisible by 64. Divisible by 64. Right? That's what by binomial theorem. If you want similar example, you can just look at it. Example number 4. It's just same question. Example number 4. Just have a look there. It's the same question. Example 4. That's also good example. What is that question? See, that question says that you prove using the binomial theorem 6 raised to n minus 5n always leaves remainder 1 when it is divided by 25. Okay, so we prove this. You need to prove this. What you need to prove? 6 raised to n minus 5n equals to 25 into some constant m plus 1. This is the remainder, remember. Okay, there's a remainder here. 1. Why plus 1? Because you have a remainder. So this number is like, 51. When 51 is divided by 25, remainder is 1. Getting me? It's like 76. When 76 is divided by 25, then the remainder is 1. So you want to prove this by binomial theorem. So how do we prove it? Very simple. You start with this expression 6 raised to n minus 5n. Then what we do? 6 we write as what? 1 plus 5. Now we know answer to this question why 6 we wrote as 1 plus 5, because I want multiple of 5, remember. Raised to n minus 5n as it is. Then what's the next step? Expand by binomial theorem, this one, right? You will see that somewhere you will find 25 common. What's binomial theorem? nc0 nc1 into 5 raised to 1 nc2 into 5 square. Then what will get here? nc3 into 5 cube and so on. Last term if you want you can write minus this 5n is already there, remember. Now here nc0 is 1, so a wala 1 aa gaya dekho. What is nc1? It's just n, this 5 as it is. Now what about the remaining terms? If you look at from here to the last one of the binomial theorem, there you will find 5 square common. अब देखो 5 square 5 cube. अंदर जो भी बचेगा it would be an integer, remember. Minus 5n as it is last में, वो तो beginning से है रहा. This will get cancelled with this. Here your 1 plus 25 into some constant. This is some constant m, remember, where m belongs to n. Right? So what you have shown, when this is divided by 25, then you have one remainder, remember, plus 1, and therefore proved. That's that example number 4. Fine. Now let's go to the last question, question number 14 here. You want to prove this. So in the 14th question, let's do that. Just you need to start with LHS, or you can start with RHS, whichever way you see. You want to prove that sigma notation, you know, it means addition. R runs from 0 to n, 3 raised to r into NCR equals to 4 raised to n. You might have noticed unit 3. So you can write here 1 plus 3 and expand it. You will get exactly this. If you want to get RHS to LHS. Or here, if I start with LHS, for example. Let me start with left hand side. Sigma r runs from 0 to n, 3 raised to r into NCR. Now I'll drop the sigma notation. Sigma means what? Addition. Sigma means what? Addition. So I'll just take r equals to 0. So here NC0 into 3 raised to 0. Then sigma means plus. What is the next value of r? 1. So NC1 here 3 raised to 1 plus next value of r 2. So NC2 here 3 square. So have you noticed? Plus what is the next value of r? 3 into 3 cube. And so on. And finally, what's the last value of r? N. So NCN into 3 raised to n. I repeat, what I did, I have just dropped the sigma notation. Take r equals to 0. So NC0, 3 raised to 0. Sigma means plus. Next value of r, 1. So NC1, 3 raised to 1. Sigma means plus. What's the next value of r? 2. So here NC2 and 3 square, r equals to 2. Sigma means plus, so plus. Next value of r is 3. NC3, 3 cube, and so on. What's the last value of r? That's n here. So NCN, 3 raised to n. What is this? If you observe, this is just 1 plus 3 the whole raised to n by binomial theorem. This is by binomial theorem. And what is this? This is 4 raised to n, which is RHS. Fine. You need to observe this. ये जो दिख रहा है आपको, it is purely this one if you remember. इसका expansion है 1 plus x the whole raised to n if you remember. NC0 into NC1 into x, NC2 into x square and so on. आप जानते हैं, you know this. NCN into x raised to n, one of the result from binomial theorem. That's what you have used here. Fine. That's so here x is 3. Okay, sigma might be new for you. I don't know whether you studied or not, but here in 11th we have one of the chapter. There we use the concept of the sigma. So there further you will realize. Don't worry right now. Just try to understand one step about sigma. I wrote NCR symbol first and then I wrote this. This is a product. I wrote this, then this. I wrote this first, then this, remember. I hope this is clear to you now.